Welcome to another video. In this system of exponential equations, we want to solve for the value of x, but by inspections, we should have guessed that the x here equals to 2. But how can we get this? So suppose these two are having the same base, and if you combine this by the law of indices, so this becomes 2 to the power of x plus 2 to the power of x equals to, this is 2 raised to the power of 6. And 2 raised to the power of 6 here is the same thing as 64. So by multiplying 2 in 6 times, so we get 64. Then we have the same base, it's cancelled, and the power remains equivalent to each other, that is x plus 2 raised to the power of x equals to 6. And what I will do here is I want to make 2 raised to the power of x the subject of the formula, and by subtracting x from both sides, so we have x is the first one, then minus x I'm subtracting, plus 2 raised to the power x equals to 6 minus x. So if these two cancelled, then we have 2 to the power of x equals to 6 minus x. And on getting this, if I try to divide both sides by 2 to the power of x, so just to have 1 at this side, or let's say I multiply 2 by 2 raised to the power minus x, so it's more of dividing 2 by 2 raised to the power x. And to make it more advanced, so I'm multiplying by 2 raised to the power minus x. So multiplying these two together, it becomes 1, then equals to 6 minus x multiplied by 2 raised to the power of minus x. Then so let's do the rearrangement. We have 6 minus x dot 2 raised to the power of minus x equals to 1. And so I want to make this power of 2 to look like 6 minus x. So I will try to multiply by 2 raised to the power of 6. So we have this equals to 1 dot 2 raised to the power of 6. From the law of exponent, we have 6 minus x dot 2 raised to the power of, so here becomes 6 minus x, or minus x plus 6, and this equals to 64. And now getting to this, so I want to follow the rules of Lambert, but to achieve that aim, so we need exponent and the ln. So if I try to manipulate these two, and it becomes the exponential of ln, we have 2, so carrying 6 minus x, and this equals to 64. Remember, so exponential and ln will stay cancelled. Okay, so if I take this 6 minus x down, we have exponential of, so it comes to the back of ln, then we bracket this, and we have ln 2 multiplying it equals to 64. So this is making sense. But since I'm following the Lambert, so for this 6 minus x, so it is missing something, which is ln 2. So if I multiply ln2 to both sides, so we have 6 minus x ln of 2, then dot exponential of 6 minus x ln 2, and everything equals to 64 ln 2. So I multiply ln 2 to both sides now, and so now I can apply the Lambert, which is w, since the power of this exponential and the coefficient of it is the same. And by applying Lambert, so we have this side remains 6 minus x ln 2 equals to w of 64 ln 2. And I'm getting this, so if I, let's say this remains the same, and if I do some manipulation here, we have w of, so this 64, if I break it down into 2 to the power of 4 dot 2 to the power of 2, then we are going to multiply it with ln 2. So because these two still remain 64, which is 2 to the power of 6. I will bracket this. And on getting to this stage, So if we keep going like this, we have this equals to omega log. We know that if this is 2 raised to the power of 4, and I have this as ln of 2 to the power of 4. Okay, don't get confused. So what I did here is, if I try to take this 4 down again, so it's still the same thing as 2 raised to the power of 2, and everything is sorted back to 64. Then, so we have 6 minus x here, ln 2 equals to the omega log. What I will do here is, if this remains 16, and for this exponential ln of these two, if I try to introduce the exponential to this, so what I will get is, I just want to try to write it in terms of exponential and the ln, and here we have exponential of ln 2 to the power of 4, that is ln 16. Okay, but is this thing really right? Yeah. So this thing, this exponential of ln 16 is only working for 2 raised to the power of 4. So which means I'm still missing ln for this 16, as that one is would be for ln of 2 raised to the power of 4. So by putting that here, we have this as ln of 16, so which is supposed to give ln of 2 raised to the power of 4, then dot exponential ln 16. So if exponential cancelled, so we have 16 at the back. And here we have 6 minus x ln 2, but the entire of all these things, so is given as around 4 ln of 2. So you can do that by pressing it in Wolfram alpha, and if these two cancel it, so here remains 6 minus x equals to 4, and from this we get the value of x as 2. So this is how this problem should be solved to me, and I know there are some geniuses there. So if you have another way of doing this problem, you can drop it in the comment box, and please subscribe to this channel and like this video. Never stop learning.